So we have to find the formula for the electric field due to finite line charge distribution. So what is the procedure to do so? So whenever there is a question when you have to find the electric field at a point, what I do is that at the point at which I have to find the electric field, that is the point P here given in this question, I assume a small test charge placed at this point and see that here due to the neighboring charges it will experience a force. The direction in which it will experience a force will be the direction of the electric field. So, okay, one thing that I have not explained this. Suppose theta 1 is greater than theta 2. What will be the case then? At that point, you can easily see that there are more number of positive charges. Assuming that the wire is uniformly charged, there are more number of positive charges at this point on the line on the line beyond this point, beyond this line to OP. So the net force that the wire will be placed, that the discharge at this point P will experience will be in this direction. It can be further resolved into components. That is the perpendicular component of electric field and the parallel component of electric field, and we can evaluate it independently because parallel and perpendicular components are always independent of each others. Okay, so this is the background. Now I will use here Coulomb's law. I am not using Gauss law here. Why I am not using Gauss law, I will not tell that. You have to answer that to me in the comment section. Okay, the only thing that we get constant here is the distance A. Raise this distance R, which is this distance. I am picking up a random point here, place that distance Y, an element of length dy, subtending an angle d theta, and the angle that it makes with respect to the origin is theta. Okay, it requires some extra space. Let's do it here. Okay, so I wanted to say that suppose there is a point theta over here, and here is the length y, and here is the length a, as in the given question. So you should be directly remembering that y can be written as, okay, let me do a step, let's not do the step jump. Y by a is equals to tan theta. So you should directly remember that whenever you see the perpendicular and you see the angle and its base, it should directly strike into your mind that y is equals to a tan theta. This is another concept, that's why I've used black ink here. You should remember it as obvious as you can. Now, what is the advantage here? As you can see, and I have converted the variables in terms of an angle theta. What will be the advantage? I will show you at the end of this video. Let's differentiate it. As we have assumed that to be an elemental length dy. So on differentiating it, you will get that the differentiating both sides, we get dy equals to a, which is constant, comes out of integration. Tan theta's differentiation will be sec squared theta d theta. Okay, so due to this element dy, at this point P, the discharge will experience a force dE. It will be resolved into the parallel and perpendicular components. Okay, let's do it here. DE, it will be a single line, remember. It is, I apologize for my bad diagram, but you can see here, it's a single line. And suppose it is angle theta, so this will be angle theta. It will be DE cos theta. Remember, it is the perpendicular component, not the parallel component in this case. DE perpendicular, because it's perpendicular to this wire. Okay, one thing, the point P is not placed in the perpendicular bisector. I have not mentioned anywhere in the question that the point P is placed along the perpendicular bisector. Yes, it is placed along the perpendicular, I can assume, for any point in the wire, but the perpendicular is not necessarily the perpendicular bisector of this wire. In the case of a perpendicular bisector of the wire, you might have understood that for getting equal contributions from upside and downside, the parallel component will get cancelled. And in this case, theta 1 is greater than theta 2, so the component will be downside. Parallel component of E, as I have said earlier, it will be DE parallel equals to DE sine theta. So let me write the expression for D at first. D is equals to, okay, the line charge distribution, the linear charge density of this wire is lambda dy. The charge, which is the charge of this elemental charge, the charge of the line element dy is lambda dy, and the electric field will be lambda dy, which is expression for charge, divided by 4 pi epsilon naught. I am writing here in terms of the magnitude. Since we are here concerned only with the magnitude, don't expect r cap or some vector terms. It is obvious, right? Because I have not used any vector notation. You may remember it in terms of the magnitude. Don't get overcomplicated here. Okay, it will be, the distance is r square. Another thing, suppose it is r. In a similar way as I use this, r, I can write this r as I can write as if I can write a as r cos theta, I can write r as a sec theta. Okay, if you don't believe me, verify it. Now from here, using the expression of using these two relations, which are the crucial ones in solving this problem, dy and r equals to a sec theta, we will now simplify it and explain and relate the change in expression of electric field not with the change in position but with the change in the angle. This is the whole purpose of this problem here. To simplify it, lambda times a sec square theta d theta 4 pi epsilon naught a squared sec square theta. Okay, now it will be some cancellations will be here. We will now get lambda d theta 4 pi epsilon naught A. This is the expression for DE. Now, as I said, that parallel and perpendicular components are independent of each other. Okay, see the diagram here carefully. I will, to find the net electric field in the perpendicular direction, I will integrate DE perpendicular, which will be DE cos theta. Okay, what will be the limits of integration? Now this is another vital important concept. I am using black ink. So this problem mostly relates to mathematics. This part relates to trigonometry, and this part includes a bit of coordinate. I understand that it is a bit tough for students who don't have mathematics in their +2 level, but still stay tuned with this video. With this problem you'll learn some. Okay, let's see how many of you remember it. This point is the origin. This angle is theta 1. What will be this angle? Theta 2. Okay, fine. Okay, I'm integrating it. So from what will be the limits of integration? Theta 2 to theta 1. Is it so? It is not. This will be theta minus theta 2. This will be the theta 1. Because I have chosen the origin at this point, and this point is below the origin. The direction of theta cap is different in both cases. To integrate, I have to move in a similar direction. That's why I have to take. I'm going through the direction of theta 1, which is opposite to that of theta 2. Means intuitively you assume that I will not go into the mathematical details because it will extend this video further. I am going from here to the point here by covering this angle. So this is the direction of theta 2, and this is the direction of minus theta 2, and this is the direction of theta 1. Okay, so this is another important thing that you should remember in this case. Minus theta 2, theta 1, d cos theta. I have broken the term in terms of d theta. So lambda 4 pi epsilon naught a, this part is constant. Let me take it out of integration. Cos theta d theta. Epsilon naught a sin theta. Don't make integration mistakes here, such as putting minus sin theta or something. Minus theta 2, theta 1, lambda by 4 pi epsilon naught a sin theta 1 minus sin minus theta 2. Okay, now I have to use another page. So remember, don't forget this part. I'm assuming you are taking notes. That will be better. If not, then I'm holding this position, camera in a position. You may take the screenshot now. Yeah, you can take the screenshot. Okay, let's go to a fresh page and complete this problem. Now E perpendicular will be equals to Okay, so one more concept for students. While solving this problem, sometimes I'm thinking whether I'm teaching physics or mathematics. Sine of minus theta is equals to minus sine theta. This is the third concept or the third takeaway from this problem. E perpendicular will thus be equal to lambda by 4 pi epsilon naught a times sine theta 1 plus sine theta 2, right? And E parallel component will be equals to lambda by 4 pi epsilon naught a minus theta 2 theta 1 sine theta d theta. I will not turn over the page as it disturbs the camera. I'm sorry for the frequency of the video, as many of you are thinking. It is not that case. Actually, it is 1 a.m. at night and I'm recording this video because I am now at home, so there is a problem in the background noise. Please adjust. Minus theta 2 to theta 1 sin theta d theta. So cos theta minus theta 2 to theta 1. Again, analogous concept, cos minus theta is equals to cos theta. So in this case, it will be lambda by 4 pi epsilon naught a cos theta 1 plus cos theta 2. Okay, so I'm unboxing these two results. Students preparing for JEE Main and NEET may not bother about these derivations, but those who are preparing for JEE Advanced, I suggest not only these derivations, but they should put their hands on other derivations as well as think about the multiple cases that how we can make this problem a bit more advanced, because the brain that the more you train your brain in this process of deriving mathematical things, it will become sharper. Okay, that does not mean that you have to do exactly in the way that it is done in the book. Even when you will try to do in your own way, you will struggle a bit. Okay, let me do a confession. I have tried to do the take 1 of this video. I never do that, but since I practiced derivations very much less in my school time, so first I did this. I'm showing you where I was stuck. I taught this part really. Okay, let me do it again. If I took the negative charge, I have to do the exact opposite case. The direction of E perpendicular will remain same, and the direction of E parallel component will be in the exact opposite direction, that is in the direction of E parallel, which I wanted to take in take 1, or I took in take 1. But I had to cancel that take because while starting to derive this, I got this point, but while doing this step, when I was recording this video, I made one mistake. That is, in the limits, first case, then while doing this, I saw that okay, in this way it will not come the result. Then I stopped the video. Then for 2 minutes, exactly 2 minutes, I had a thought, and on the same page I solved it using my own hand and came into this result. So don't think that I'm seeing book and doing anywhere. My only point of saying this to you is that if you do get stuck into a problem, that is actually a good thing, because that will make your brain more trained. and don't feel shy if you get stuck. It happens. Okay, this problem is solved. So how many times we have passed? 20 minutes have already passed. So you can take a screenshot of this case. So I have completed this derivation. Okay, some important insights that you can take from this problem. I have taken the most general case in this problem, which is the electric field. I have taken what I have did. Let me tell you in short. I have founded the electric field for a point which may be placed at any random position, not necessarily at the perpendicular bisector. But let me derive the positions, derive the equations that will also come in perpendicular bisector. What will happen in case of a perpendicular bisector? In case of a perpendicular bisector, theta 1 and theta 2 will be equal. What will happen in this case? Suppose it is equals to theta. In this case, E perpendicular will be equals to. I am removing the black pen because I suggest don't remember these methods. It will not help. Don't remember this result. Remember only these two results if you want to. These two will help you in the long run. Still, for some things I'm giving this for more information. These are only practice things. It will come on your own. It will be 2 lambda sine theta 4 pi epsilon naught a. And what will be E parallel? E parallel will be equals to lambda times 4 pi epsilon naught a E parallel component will get cancelled here. And E perpendicular component will get added here. Okay, one error that I have done, that is the error that I have shown here. The reason for this error is step jump. I have step jump, that's why I made this error. Whenever you do this integration, there will be a minus and there will be another minus here. Okay, so I apologize you. For pi epsilon naught a cos theta 1 minus cos theta 2. Yeah, now fine. Another insight, don't do step jump even at a minus step. If you solve neatly with every step, it is for your own benefit, not for the benefit of others. Okay, so cos theta 1 minus cos theta 2, this is the case. And in this case, what will be this case? E parallel. So it will be cos theta minus cos theta. Cancel out, it will be 0. At this point, I realize how it is wrong. Okay, so this thing is also important. Don't make mistake here. If I'm making mistake here, that means many students can make this mistake even if you don't. So if you take this point in your mind, it will be very cutting edge in this competition, as it happens in case of competitive exams. Okay, so that's it. I should end this video here. Okay, it may take a time to upload this because I don't have Wi-Fi connection at homes. Okay, so that's it. Okay, before ending this, let me give you some updates about my upcoming winters. So as I've created a poll 2 days earlier, I have got 2 votes in it. The 2 votes were showing that most people want videos for electromagnetism. So I will stick to the poll and will be uploading electromagnetism videos for this whole month of December. And I will try to increase the upload frequency compared to November. So because I'm at home, there is some problems in the upload, but I will try to record videos much faster. Once I reach the institute, I will try to upload them all together. Okay, I thought of going live, but I don't have the access to go live because I'm very much less subscribers at this moment. Okay, that's it. I've talked a lot.